that one that you're currently working on. Okay, wonderful. So we have two drawings here. This one is of a cube. This one is of a room. But in the room, let's just focus on the coffee table. So what are the differences in some of these drawings that you see? Can you see them okay?
There's more perspective in the one on your right.
Okay, so what do you mean by perspective?
Well, perspective point that you reach space to account for physical limitations and picture, and everything goes out in there.
Okay, what do you mean goes out?
Like, if something further out from the perspective point, that makes it as people go back, and as you go closer to it, it becomes further away. So can you tell with more perspective, and you have 2 points, and you're looking to get something at an angle that is, I guess we are.
No, go on. Yeah.
But basically the idea is it helps you understand how like an eye is looking at something and the way things are. So the perspective points represent the part that your eye sees furthest away from it.
Okay.
Where it crosses or where it charges to something that's closest to you.
Okay, so if we're actually looking at a square or like a coffee table, what do we notice about distances as they get further away? Yeah, they shrink somehow, right? That's weird, right? Because like a coffee table, if I go and we measure the distance, if I stand over here and I measure the distance, what should be the distance on this side?
Same.
The same. Okay, well we have a rectangle, and so what are we learning about rectangles? Opposite sides should have the same length, maybe? But in perspective drawings, they don't. Weird, right? I don't know. I think that was kind of interesting. Thank you for letting me look at your drawings. So, let's make a few more observations about perspective drawings, or about drawings that look real. Basically, that look like, if I took a photo of it, that's how it would look. That's what I mean by look real. So let's look at this drawing, or this picture. What are some things we notice?
Angles in, even though presumably the walls are parallel to each other.
Yeah. If I were actually walking in this art building, as I pass through this hallway, would the walls actually shrink on me?
No.
No. But what do they do in this picture? They do. Weird. Okay. What about, notice the lights up here. What shape are those lights? What would we say they are? They're rectangles. But do they look like rectangles here? No. No. So there's this weird, I don't know, weird stuff is going on if we look at the geometry of our photograph. So also this example, I don't know, what are some other things we notice? Different things maybe. Okay, yeah, so these lines say that are formed by maybe the windows and these overhangs. We consider them parallel. They can never meet. We would never see their point where they meet. But yeah, in this picture they do. They seem to meet. And this picture kind of makes that more explicit. Okay, cool. So just to summarize some of our observations, some things we noticed. What about parallelness? What happens with parallelness on pictures?
It converges, so it doesn't look parallel.
Yeah. We don't really have parallel things. Everything intersects. As parallel as we know it is not really the same. Okay? Weird. And what about distances? Yeah, they're not preserved. If we look at a snapshot, the distances are not how we'd actually measure. Awesome. So we want a geometry that captures this, where parallel lines on the ground intersect in some point on our drawing board. And so today we're going to kind of explore how we can understand the geometry of these photographs. Cool. So now we're going to introduce an object, like I said, that you guys have seen before, the real projective plane. And to start, let's just recap a little bit about this object. So what were some things, oh, I guess I gave it away, the first bullet, but what were some things about the projective plane that we saw last week? In terms of parallel lines? Yeah, any two lines intersect at a point. So we want to some way capture our world, our camera photo, but we want all lines to intersect, okay? Cool. So how Bianca drew this yesterday was, or last week, was a picture of the real projective plane, and then she included the points at infinity somehow. We'll look at that again, but I just wanted to review that for you all. So here was her definition, and let me just draw that to refresh our memory. So we call it the real projective plane. And here's one view of it, or definition. So we start with R2. And now we want every point in R2 will be a point in our projective plane, fine. But what we want to do also is if we have two lines that are parallel, we want there to be a point where they intersect. So what do? Well, with any collection of parallel lines, we'll just say, let's call this collection M. We'll just mark it by their slope. We'll throw in a point somewhere. Okay, so we could see this as just plain old R2, and then, oh, let's just look at this other line here, where we're just marking each slope. Does this sound familiar? Okay, awesome. Well, this definition to me feels a little weird. Okay, it's like, really? This line somewhere that exists, we just throw it in? Well, where is it? You know, I don't feel it. So, the definition that I like better of the real projective plane is that all of the points are just lines through the origin in R3. Okay, what do I mean by this? Well, to get more familiar with this definition, I'm going to step back a dimension, and we're first going to look at the real projective line. Okay? So, for the definition. The real projective line, we call it RP1, is the set of all lines through the origin in R2. So a point here is a full line in R2. So I'll draw a picture of this. Call this RP1. And so we start with R2. But now every point that I have is just a line through the origin. So this whole line is one of my points. This line is one of my points. Okay? And so how we can mark these points is, well, I could just pick any real, point in R2. So let's call this one, I don't know, 2, 1. And to represent this point, that is the line through 0 in R1, I can just write this as, with square brackets, R1, like that. Okay? So now we're going to do a little exploration in the real projective line to get some familiarity with it. So I have a handout for us.
The question set?
Yes, please.
Okay.
To sort of just get a little bit more acquainted with this object. All right? Any questions about this definition? How does it feel? Is this boring? Or is it kind of oh, okay, it's kind of weird, but whatever. It's not too bad. Yeah? Is that kind of? Okay. Cool. on the first section of questions. So number one.